In the last few examples, we set up linear equations where the values for the equation were directly given to us. We just had to read and interpret those values and know where to plug them into the equation. In the next few examples, we're going to have to complete some calculations to find some of those values. In part A, we want to write, in example 3, part A, we want to write an equation for this scenario where a company manufactures a product with a given fixed cost. The total costs are given per day at a daily output of 17 items. And we want to assume that total output per day, X, and total costs are linearly related. The fact that there's this linear relationship tells us that we want an equation of the form C equals mx plus b. Then we need to look at the problem and determine what information we're given. We're told we have this fixed cost. That's our value b in that equation. And we're given a value for total cost, which is going to be our value for C, at a daily output of 17 items, which corresponds to our X variable. What that means is we can set up this equation by plugging in those values from the problem. To see that what we're missing is the slope of this linear equation, that value for m. In order to solve that equation, we can jump over to Symbolab and we can ask it to solve this equation, which is 2509.59 is equal to m times 17 plus 482.95. Click go or press enter to evaluate, and we'll get a slope of 119.2141 if we round that to 4 decimal places. Meaning our equation for total cost is 119.2141x plus 482.95. Now that we have that linear equation for total cost, in part B we can find the new total daily cost if production increases to 37 items per day. To find that, we'll again make use of Symbolab, and we'll ask it to evaluate the expression that we just came up with for x equals 37. We do that, we get a result of 4893.8717. Or the way we'd want to input this as an answer for our homework would be to convert this to $4,893.87. Since C represents total cost, that number reflects money. Money always has two decimal places, so we would inherently know to round that answer to 2 decimal places. In example 4, we have a scenario where a company can manufacture 78 items per day at a total cost of $5,797.62 and 80 items per day for a total cost of $6,631.27. We want to assume daily cost and production are again linearly related. We want to find an equation for the total daily cost for this company, meaning we want an equation of the form C equals mx plus b. In this case though, what we're given are 2 xy coordinate pairs. We have a production level and a total cost, so we could call those x1 and y1. Then we have a second production level and then a total cost that's associated with that. Grouping those as 2 coordinate pairs, what we can do is ask Symbolab to find a line through those 2 points. So 78, 5797.62 and 80, 6631.27. And Symbolab will output that equation, y equals 416.825x minus 26714.73. That gives us our cost equation. And then in part B, we can use that cost equation again to find the total daily cost of producing 65 items. To do that, we'll again enter the expression that we just came up with in part A. First, we want to make sure we say evaluate. 416.825x minus 26,714.73 for x is equal to 65. We get an answer of 378.895. Or, since again, C represents total cost, we know to intuitively round that to 2 decimal places to get $378.90.